When creating sex-linked trait Punnett squares, it basically works the same as the normal dominant recessive Punnett squares that we did last lesson. The only difference is that you are using the sex chromosomes. Since the sex chromosomes are not necessarily a homologous pair of chromosomes, there is some variation in the way you set up the square. So in this case, we're going to look at any random dominant allele that's attached to the X chromosome and a recessive allele attached to the X chromosome. For this cross, we're going to look at a carrier female crossed with a male carrying the dominant allele on his X chromosome. So to set this up, you draw your square. You show the possible gametes the female can create, which would be eggs that carry the X chromosome with the dominant allele, or eggs that carry the X chromosome with the recessive allele. For the males, they're going to create gametes that either have the X chromosome with the dominant allele or gametes that carry the Y chromosome. This is where the difference is. Since the male only has one X chromosome, whatever trait is attached to that X chromosome will be expressed in the phenotype. Whereas with the female has two X chromosomes, so the alleles follow the regular rules for dominant and recessive traits. If you have one of each, as in this case, a heterozygous pair, then the dominant trait will be expressed in the phenotype. Now when you fill out the possible outcome for the offspring, you're going to show how these gametes combine. You will have more options than you do in a regular Punnett square because you have an XX combination and you have the XY combinations. So in this case, there is a 25% chance of having a female offspring that is homozygous dominant for that trait. There's a 25% chance of having a female that is heterozygous for that trait. In this case, those female offspring would be called carriers because they carry the trait. The other options, you have a 25% chance having a male offspring with the dominant allele, and then you have a 25% chance of having a male offspring with the recessive allele. In this case, if the male inherits the one X chromosome with the recessive allele, he will have that recessive trait. Whereas for a female to have the recessive trait, she would have to carry the recessive allele on both X chromosomes. So that would be X with the lowercase, X with the lowercase.